Good morning, Year 6. Thank you very much for all your efforts this week. I've been really impressed with everything I've received so far. I'm particularly impressed with Talia and Layla, how much you're sending in terms of thinking about each subject. Ines, I really like how you're breaking down when you send things in. It actually helps me out a lot. But I'd also like to say that I'm really pleased that you're addressing every single subject. You're thinking about your answers as well. And Nathan, I know you're thinking about them in your head, but it'd be great to see you thinking about them a little bit more on the page. So keep going with that, guys. And Jeremiah, keep up that fantastic presentation. All of you are really impressing me with all your efforts. So thank you, Year 6. Let's keep going with that as we go through this period. Today, in your main session, so I say, you're going to be continuing with your work from yesterday on representing fractions as decimals. So looking at how you can represent fractions as decimals within that session. The session that we're going to look at together now, though, is going to be focusing on prior knowledge about how we look at length and angles in shape. Okay, so we're going to consider that. And as we're doing that, we will be wanting to think about what we know already and how we can understand that and how we can use the language of that. So thinking about this, if we look at this shape, we can see it's a five-sided shape. So this green shape that's come up on the screen. It's a pentagon. Okay, it's an irregular pentagon, and I know it's irregular pentagon because the sides are not equal. I can see that quickly. Now, I do, however, know it's a pentagon. So what does that tell me about the angles within the shape? A, B, C, D, E. Does it tell me anything? Or at the very least, can I identify what type of angles some of them are? Can I identify any obtuse, acute, reflex angles? What can I identify? Have a think what you can identify. Pause the video while you ponder that, while you consider that. Now, I can tell that all five of those angles together, the sum of them is 360 degrees, because that line that cuts across above D and E, that line that cuts across this pentagon, the A, B, and C are going to be 180 because they're on a line, and D and E together are going to be 180 because they're on a line. And 180 add 180 makes 360. I can also see that that line that cuts through with A and E to one side of it, A and E therefore are going to be 180, and B, C, D are going to be 180. If I was being really, really clever, I could also spot which ones are obtuse, which ones are reflex, and which ones are acute. Now, looking, I can see that none of them are greater than 180 degrees, so none of them are those reflex angles. I can see, however, that E is definitely larger than a right angle, and consequently, that would be an obtuse angle. And I can see that both A and B are definitely below 90 degrees, below a right angle, and consequently, both A and B are acute angles. Now, remember, small things cute. Okay, think of me. I'm very big. I'm not remotely cute, so I'm the opposite. So acute angles are smaller angles, less than 90 degrees. Okay, right, guys. Now, as I say today, we're thinking both about angles and about length, and we're trying to kind of recall what we know. So, looking at this piece of work, we've got some information, but not lots. We've got here a six-sided shape. So we've got an irregular hexagon. Okay, six sides, and we can see that we're trying to identify the length of A and the length of B. Now, the only other piece of information we've got is that two squares on the left-hand side indicate 14 centimeters. Now, I'd like you to pause this while you identify how long A and B are. If you're not sure, we'll talk through some steps in a few seconds. As I say, lots of us will have spotted that 14 centimeters is key here, that it's the distance for two squares. Now, if 14 centimeters is two squares, one square will be, well done, 7 centimeters. I'm sure lots of you said that either in your head or out loud. Now, if I know that 14 centimeters is two squares, I know one square is 7 centimeters. I know that A is 4 squares along, so I'm going to do 4 times 7. 4 times 7 is, lovely job, 28 centimeters. And then I know that B is also 2 squares long, so I know that B is going to be the same as the 14 centimeters. Okay, so I can work those through. Hopefully we've managed to do that on our own. If not, hopefully now looking at what the information we had on the screen would have helped us to solve that. Looking at these then, rather than the length, we're now thinking about the angle. Now, we've got A, we've got B, we've got C, and we've got D. What do I notice? Well, I notice there's something special about the line above B and C. It's a horizontal line. and that the line that cuts through B and C is a vertical line. So I know that the relationship is like a capital T, and therefore that tells me something about both B and C. I know that C is double the angle which is shown by D because of the way that the diagonal line going up from the bottom left corner where D is at that angle. I know as well that A is what I'd get if I added C to D. So if I look at these angles, what can I identify about them? As I say, the first thing I spotted was that capital T where B and C are. See what you can identify. Pause this and see if you can work them through. Lots of you spotting this, which is great. First ones I spotted were B and C. Both of them then are 90 degrees because they're both right angles. The horizontal line and the vertical line are intersecting like a capital T. Now, I know that 90 degrees is a right angle and that D is half a right angle because the diagonal line cutting across from D is cutting right through the corner at the top right hand of that square. Therefore, half of 90 is 45. I know that the obtuse angle, which is indicated by A, where the right angle additionally with the extra half of a right angle is going to be 90 plus 45 degrees, and therefore that's going to be 135 degrees. Lots of you will have worked that through anyway, but just to tell you how I managed to solve it. Right, guys, got a bit of a true or a false here. What do you think? Is A 16 centimeters? Are you going to get your ruler out, or are you going to look at the scale? I'm sure all of you are going to look at the scale and figure it out from there. Okay, let's see what you've spotted. Well, have you divided 11 by the number of squares? Do you need to? Hanya's going, no, Mr. Spring, stop wasting our time, Mr. Spring. Stop it, Mr. Spring. And you're quite right, Hanya, because 11 centimeters indicates 3 squares. Well, how long's A? 3 squares. Well, is 3 the same as 3? Yes. So 11 centimeters is the same as 11 centimeters. Okay. Yeah, so it's false that A is 16 centimeters. Here we've got some information, some of which are angles, some of which are lengths. Okay, so I can see A, B, C, and D. B and C look to me like they're internal measurements, and therefore they're going to be angles. B, A, and D are external measurements, therefore they're going to be lengths. Now I can see that A is smaller than D, therefore I'm looking for my longer distance for D. I can see that B is an obtuse angle, whereas C is not an obtuse angle. It is either equal to or less than a right angle. What's your answers? Pause while you work them out, please. Great stuff as you work through, guys. I can see lots of you have spotted those correctly. Thank you for that. Okay, guys, last little thing. We've got Adam here. He thinks he's chosen the correct angle for the total degrees of A and B. He's looked at A and he's looked at B, those two acute angles, and he's spotted that collectively he's decided that they are 135 degrees. I think he might have spotted that there's a right angle on this shape and he's added half a right angle to that. Let's see. What do you think? Do you agree with Adam? Is Adam a clever clogs or is Adam having a bit of a moment? What do you think? Lots of you looking through, lots of you thinking he's wrong. He's not correct. It's correct from you who are saying he's wrong. And the reason he's correct is because, well, both A and B are 45 degrees. They're half a right angle each. We can see that because of the diagonal line which is going from that angle cuts through the square, the corner of the square. And therefore, half a right angle, add half a right angle, makes a whole right angle, makes 90 degrees. Okay, guys. Pause while you try and work through this sheet, please. If you're finding any of it challenging, just have a look at what you know based on the diagrams. You know for 5A that 24 centimeters is the same as 3 squares. Well, what would 1 square be then? And if I know what 1 square would be, what would 2 squares be? D is indicated. Okay, what do I know for 5B? I know that 2 squares are worth 12. So what's 1 square? If I know what 1 square is, what would 5 squares be, which is what D is indicating? Looking at my angles, well, I can see that the diagonal line that goes from point B cuts through squares, so it's going to be half a right angle. What would that be? And I can see that C is a right angle. Add that half a right angle. So what would that be? Something special about the type of angle on 6AA. Let's see how you did. Okay, looking at these guys, we can now see A is 40 centimeters, B is 24 centimeters, C is 24 centimeters, and D is 16 centimeters. Okay, we can see for 5B, we've got 18 centimeters, 12 centimeters, 6 centimeters, and 30 centimeters. And then you can see the different degrees values for 6A and 6B. Having a look at the second set of work, if you manage to do the first set, great. Second set's trickier, so you really do want to pause this while you work through these. Okay, looking at side A, 7 centimeters long. Well, if I know that something's 7 centimeters, I know that I'm checking whether the other measurement is 2.5 centimeters. Dividing 7 by 3 is tricky. I'm not sure I want to do that. But maybe I could do the inverse with the value I do have. I have 2.5 centimeters, and I want to see whether 3 squares are the same as 2.5 centimeters multiplied by 3. Well, 2.5 times 2 is 5. 5 add the 2.5 is 7.5. So is that true or false? Looking here, the internal angles of a triangle, guys, always add up to 90 plus 90. So it's always 180 degrees, the 3 angles that make up a triangle. See how you get on with the other ones. Let's see how we've done. Okay, guys, 7.5 rather than 7 centimeters. 34, because 34 plus the 56 makes 90. 90 plus the right angle of 90 makes 180. We can see the values for E, A, B, D, and C for the other 2 questions. Well done for working through these. Now, within your work today, you've got the sheet that looks like this. And as part of that, I'd like you to really make sure when you're looking at question 7 that you work carefully through each step. Don't rush to an answer, and particularly the point where it says, are there any other possible answers? Now, I know you can't talk to a partner unless you're lucky like Layla and Talia and you have a ready-made member of Year 6 with you in your house. But what you can do is maybe think about what discussion you would have. Okay? Now, thank you very much for listening today, Year 6. I look forward to seeing you all soon. Goodbye.